Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on vectors and scalars. This is the beginning of a new unit in which we will be learning more about vectors. We will also learn about the transformation of plane figures. Today, we are going to revisit what you have already learned about vectors and scalars and look at some of their everyday applications. Are you ready, students? Let us begin this unit. Do you remember the definition of a vector quantity? How about a scalar quantity? Please take a moment and see if you can recall the correct definitions for each of these terms. How many other quantities can you name for each type of measure? In groups of two, please list as many as you can. Go ahead now, students.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I am confident that you were easily able to remember what you learned in the previous grade. A vector quantity is defined as a quantity that can be completely described by stating both its magnitude in a particular unit and its direction. By contrast, a scalar quantity is completely described by its magnitude expressed in a particular unit. Were you able to recall these definitions? Good work. Now that we have been reminded of the natures of vectors and scalars, do you remember the different quantities that they can be used to express? For example, a vector can be used to express velocity, whereas a scalar can be used to express time. How many quantities were you able to list? Let us name all the different quantities and see what you remembered. We have already been reminded that velocity is a vector quantity. Some other examples of vector quantities are acceleration, displacement, momentum, force, and impulse. I hope that you are able to recall all of these. There are more examples of scalar quantities. In addition to time, you could also have named speed, distance, energy, electrical discharge, density, volume, length, temperature, mass, power, and work. If you remembered these quantities, great work. This is a graphical representation of a vector. This vector is called v. Its initial point is on the origin, and its terminal point is located at x and y. X and y are called the components or the coordinates of v. The coordinate form of v is expressed this way. We could also write it as a column vector like this. Do you remember how the magnitude of a vector is expressed, students? That is correct. The magnitude of a vector is expressed by its length. If we want to determine the magnitude of vector v with coordinates x, y, we calculate it by finding the square root of the sum of the squares of the coordinates. Apply this formula yourselves, students. If vector v is expressed by the column vector of 4, 3, and its initial point lies on the origin, what is its magnitude? Please go ahead and answer this now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, students. Let us see how you fared in this exercise. I am sure you had no trouble. We know that the magnitude of vector v is expressed by the square root of the sum of the squares of its coordinates. Since the coordinates in this case are 4, 3, the squares are 16, 9. The sum of the squares is 25. Therefore, the magnitude of vector v is the square root of 25, or 5. Well-remembered students. You can see that calculating the magnitude of this kind of vector is very simple. However, what if the initial point of the vector has its own set of coordinates? Here is a different vector called st. As you can see, its initial point does not lie on the origin, but at coordinates 2, 2. Its terminal point is at 8, 10. Can you remember how to find the magnitude of a vector whose initial point is not on the origin? With the same partner as before, try to remember the formula for this operation and apply it properly. You can get started right away, students.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello again. Did you and your partner remember the proper formula? The magnitude of vector st is equal to the square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. If we find the difference between the second set of coordinates and the first, then square the difference and find the square root of their sum, the magnitude can be calculated. Follow along as we practice this technique. After we substitute the proper values, our formula looks like this. Magnitude equals the square root of the difference of 8 and 2 squared plus the difference of 10 and 8 squared. The difference between 8 and 2 is 6. The difference between 10 and 2 is 8. When each difference is squared and added, the sum is 100. The square root of 100 is 10. Therefore, the magnitude of vector st is equal to 10. By following the same series of steps, I am confident that you found the magnitude of uv to be equal to 13. Good work, students. I can tell that you are diligently applying yourselves to your studies. That is all for today's lesson. We have reviewed the definitions of vectors and scalars and what each can be used to express. We were reminded of how to express vector coordinates and calculate their magnitudes. Next lesson, we will practice operations of vectors. Until then, thank you, teacher. Thank you, students.